right there. So the start to all of these is this. So we know that A is that. So if that's what it is, what is velocity? Well, you integrate that, correct? How do you get from here to here? You integrate. So velocity is going to be negative 32t plus the initial velocity. And then how do you get from here to here? You take the antiderivative again. So what's the antiderivative of this piece? Well, that's going to be negative 16t squared. That turns into v naught t and h naught. I say this, how do you pronounce that? It's not v0. What is that? V naught. How do you pronounce, or how do you spell naught?
K-N-O-T.
That's a not you tie. Not. N-A-U-G-H-T, not. All for naught. It means nothing. It means nothing. So v sub 0, the way you say that is v naught. So v naught, another way to say v naught is initial velocity. And what does h naught mean? If this is initial velocity, what's this? Initial height, exactly. Okay, so let me clean this up a little bit here. So is everybody okay with these right here? Is everybody okay with these?
The 32 is just
It's the universal constant for Earth.
Okay.
Earth. Earth, 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 Earth. On Earth, the acceleration due to gravity is negative 32 feet per second squared.
You accidentally erased negative 16.
Oh, thank you. So this is negative 16. Thank you very much. Are you okay with that now? Right. What happens if you go to another planet? What changes?
The
Acceleration due to gravity. Exactly.
Would you calculate that?
What?
Would you calculate that?
Calculate what?
Or would you, say you had give us an equation where it's on Mars. We have to find that.
I guess there's a way I could set that up, but I've never asked that kind of question. It's a good idea. I'll add that to your final. Good job. Okay, so you're like, ha, trick's on you, Mr. Seamon. There is no final. Like, well, I could give you a test right beforehand. It's not the assessment. You're like okay. A woman standing on a bridge throws a stone up. Exactly 5 seconds later, the stone passes the woman. So you have to figure out a few things here. So first of all, what is it telling you? Exactly 5 seconds later, the stone passes the woman on the way down.
So she throws it up enough for it to pass her 5 seconds later.
5 seconds later. So at 5 seconds, what does that mean? Is the velocity the same as when it started? Is the acceleration the same? The height is the same as when it started. That's this one right here. That's this one, if I can actually get it. That one right here. At the height at 5 seconds is the same at height at 0 seconds. And then what is this? What does this represent here? H of 0 is 0. H of 6 is 0. What does that represent? No, it's not ground. What is it? Well, it's ground, but it hits the what? Hits the water. So the water is height 0 right there. Is everybody with me so far? Okay, everybody's there? Okay, so let's take a look at what's going on here. Let's take a look at what's going on. Let me pause a little bit here. Okay, right here, you plug in 5, and what do you get? Well, you're plugging 5 into the height equation. That's this one right here, correct? How many variables are in there? Height is the output, t is the input. How many variables are there? How many unknowns? There's c, and what else is there? K. T is the input, h is the output. The two things you need are c and k. In this case, c is the same thing as v sub 0 or v naught, and k is what?
H naught.
H naught, exactly. This is the variable names change. That's fine. So you plug in 5, and what do you get? This right here. You see that? You plug in 0, and what do you get out? What do you get when you plug in 0 into the height function? You just get k. So are you okay with these two things? So you know that h of 0 is h of 5, so therefore these two boxes have to be what? These two are equal to each other, so therefore what? Those two have to be equal to each other. So you know that these two right here are equal to each other? You with me so far? So what do you end up with? Let's keep on going here. Well, there's the negative 400 right there. And then what is there? There's... Oh, the k. Oh, isn't that cool that the k's cancel on both sides? What? Now you just have to solve for c. But here's the thing: usually one equation in two variables. Can you solve for either of the variables? No. If you have two unknowns, how many equations do you generally need? Two. But in this case, what cancels from both sides?
So one of the variables.
One of the variables cancels completely on both sides, right? So what are you left with? Negative 400 plus 5c is equal to 0. So therefore 5c is equal to 400. So what does c equal? 80. So c is equal to 80. That's right here. There it goes. So what are you still left with though?
Still left with the initial height.
Yeah, you still don't know what the initial height is, but do you know what the initial velocity is now?
Yeah.
The initial velocity is 80 feet per second. Anybody know how fast 80 feet per second is about? Though we use this one. What haven't we used? H of 6 is what? h of 6 is 0. So we have this function we have this right here. See this? Right there. What can we plug in now? H of 6 is 0. So you plug in 0 here, and you get this. 0 equals that. So what did we plug in for t? 6. So did we find h naught? Yeah, we got 96. So now do we have this height function? We sure do. What?
Where's the 6 come from?
The 6 comes from the statement after 6 seconds it hits the water, right? H of 6 is what? 0. H of 6 is 0. So you use that, and now you have the entire height function. Nice. So you haven't answered the question, though. It says, find the initial velocity of the stone and the height of the bridge above the water. So what's the initial velocity? Hold on. What's the initial velocity? 80 feet per second. And then what's the... It's not 8 feet an hour. It's feet per what? Feet per second. And then what's the height of the bridge above the water? It's going to be 96 feet. Yes, no. Now what's your question? You got it now? Effectively, this is just asking you to integrate, solve for two unknowns. That's it. I know this is almost an impossible question to answer, but what's the most magical thing that happened in all of this work that really helped us out? What was the first big thing that was super helpful? The K canceling is super huge. You can do this without that. You'd have to use both equations at the same time, the height function and the velocity function, and cancel stuff out. But in this case, it's super nice. That is super, super nice. So you guys asked about 7 as well. Really good question. A car starts at rest. Can we just call it rest? And has an acceleration. Nice. How long does it take the car to go 200 feet? So we have the acceleration. We really want to get the position function, right? So this is the whole goal here is to get the position function. So we know a of t is what? 0.2 t plus 6, right? What can we if we anti-differentiate, what do we end up with? Which function?
Antiderivative.
Which is called the antiderivative of acceleration is?
Position.
No. Velocity. Try again. So what's this one going to anti-differentiate to? Can someone tell me?
0.1 t squared.
Yeah, so 1/10 t squared plus what?
6t plus c.
Plus the initial velocity. We'll call it v naught, right?
T is such a horrible variable here.
Yeah.
If you don't put that little curl on your t.
Correct. If you don't, it really is not. And I like putting parentheses there. So let's keep on going here. So what's the position function going to be? Or we don't usually use h. What do we use for position? It's s of t. So what's s of t going to be? Can someone tell me what the antiderivative is now? Someone new? Mark, what is it?
Wouldn't it be 1 over 20?
No, because the 2 drops to the front. 2 over 10 is 1/5.
But 2 over 10
is 0.2.
is 1/5.
So can someone tell me what the position function is going to be? 1 over 30. So it's going to be 1 over 30 times t what? Plus what t? Careful. 3 plus v naught t plus what? We'll call it s naught, like the initial position, right? Is everybody with me so far? So now it says a car starts. So when you have the acceleration, we have the velocity, and we have the position. How long does it take the car to go 200 feet? That's a really good question. Now, how many unknowns do we have in this position function?
2.
We have 2. We have initial velocity, and we have what? Okay, so is there any more information in the initial equation that we haven't used yet? There's one piece of information we haven't used. It starts what? That's what part of our answer. We want to know how far it goes, but what's the initial? No. It starts at rest. What does that mean? V naught equals what? 0. So we know that this right here is what? 0. So what does this have to be? Are you with me so far? Every time I plug something in, I like to summarize what I now know. So now I know that what's the position function? 1 over 30 what? Cubed plus what? That's not, a car starts at rest. So I have a question. Does this really matter right here? How much does this matter, this initial position? What? Well, what's the question asking? The question.
Not much, because we're asking about time.
How long does it take it to go 200 feet, right? How long does it take it to go 200 feet? If it starts a certain place and goes 200 places, it doesn't matter where it starts, right? Does everybody understand what I'm saying right there? Yeah. So what function? We have that s of t function right there. 130 t cubed plus 3t squared plus s naught, right?
We don't need s naught.
S naught is going to be the same. So like, for example, this is what I mean. Ready, everybody? So at time 1, how far is it gone? Let's just do S of 1. That means where is it at time 1? What do you plug in for t?
1.
So it's 1 over 30 t cubed plus, not t, what do I plug in there? Plug in 1 cubed plus 3 times what? 1 squared plus, do we have any idea what S naught is? No. Well, what's S at, let's say, 5 seconds? What's that going to be? Well, 1 over what? 30 times 5 cubed plus 3 times plus S naught. So this is where the function is, this is where the particle is at 1 second, right? Or car, whatever. And this is where it is at 5, right? If you want to know how far it's traveled, how do you find out how far it's traveled? This is its position at time 1 right here. And then this is its position at time 5.
You'd add them together?
No. You would not add them together. You would subtract them. If you started 3 miles away from home and then you ended up 10 miles away from home, how far did you travel? 7 miles. How'd you get 7? You subtracted, right? If I was 1 kilometer away from home and then I traveled to 10 kilometers away from home, how far did I travel?
9.
If I traveled in a straight line, 9, right? How did I get 9? 10 minus 1. So if I have two distances here, if I have two positions, how do I get the distance traveled between them? I what? What happens when you subtract them? What always cancels? If I were to subtract these two things, what cancels? The S naughts cancel. Do you agree? Do you agree with that? So is it relevant when you're calculating distance traveled between two times, Arvin? Does it matter what the S naught is? Everybody, does it matter? No. So we go back up here. We have our distance function right here. We have our distance function right here. So what are we interested in now solving? If we want to know how long it takes it to go 200, what am I going to set what equal to? What two things am I going to set equal? So it's going to be what? 1 over 3 t.
It's 0.1.
0.1? What? No, I circled the black one. The black one is position. So what's it going to be? 1/30th t what? T cubed plus equals what? Equals 200. Equals 200. Because you want that part to be 200. Because what happens at time is 0? When you plug in 0 into this, what do you get when you plug in 0? When you plug in 0, what do you get? S naught, right? So you want that thing to increase by 200. Do you understand what I just did here? This is super important. So think about it this way.
You just plugged in 200.
No, I didn't plug in 200. I set it equal to 200. This is our position function. S of t is equal to 1 over 30 t cubed plus 3t squared plus S naught. Are you okay with that? Hold on. I'm going to explain it. Just watch for a second. Are you okay with that?
Yeah.
Okay. So you want to know it goes from time equals 0 to some time to position, let's say, A. At time equals A. What is S of 0? When you plug in 0, what do you get? When you plug in 0 into this, what do you get? No, you do not get 0. You get S naught. Do you agree?
Yes.
When you plug in at A, you still have S naught, but when you subtract them, what cancels? Like, what is S of A? 1 over 30 what? Cubed plus 3a squared plus S naught. If you want to know the distance traveled, like I just explained, what do you do with those two things? And what cancels? The S naughts. And what are you just left with? You're just left with that. 1/30th a cubed plus 3a squared. So what do we need to do? We need to set that equal to what? Because that's how far we want to travel. Yes, Arvin.
Why do we set
Solve this. Tell me what's the first thing I should do. To the left side. Don't say divide.
Square root also keys back in.
Factor. What can I factor out, David?
2t.
Careful. Nope. T what?
T squared.
T squared. So when you factor out t squared, what do you end up with?
130t plus 3.
Exactly. So you get t squared is 1 over 30t plus what?
3.
Equals?
200.
200. Exactly. So you could work with this right here and see, oh, wait. If it equals 200, it doesn't equal, we want it to equal 0, right?
Mm.
Correct? Does everybody see what I mean? You want it to equal 0? Do you have any way of doing this one by hand? What do you think? Well, when you factor, what was your first step when you factor, Natalie? What was the first thing you generally try to do when you factor? Do you remember? You want it to equal what? 0, right? So if we move the 200 over, we want this. We want to see if can we factor this. Is this something that it looks like we have factored before?
Yeah.
Really? We factored cubes like that? It's not impossible. I like your confidence. You're like, we're good. We'll try it. But
I've seen worse.
it's not. I've seen. Well, no, it could be worse, right? I mean, usually you don't like that 1/30th, right? So what would you do first? Let's just try factoring it and see what happens. What do you do? Times 30, right? So what do you get? T cubed plus 90t minus what? 6,000. Hey, at least they're not horrible, right? But now you need two numbers that multiply together. Oh, wait. What do we get here?
3t squared.
Oh,
90t
90t squared.
squared.
Yeah. So you're like, oh, man. Anyway, the point is, does this look like something you can factor? So what would you need to use? X. So when you do this out, you end up with y is equal to what? Negative cosine x plus 2x plus c. Yep. There is the general solution to the first order. Fantastic. So what about this one right here? This is exactly the same thing, except it's a little bit more involved. First part. So it's going to be y is equal to what? 2 to the x over ln 2. Nice. Plus what? Plus. Oh, so that would be the general solution, right? But you now have an initial condition. So when you plug in 0, what else? What do you get out? 5. So well, hold on. When you plug in, you get 5 equals 2 to the 0 over ln 2 plus c, right? Correct? What is 2 to the 0? 1. Careful. So 5 is equal to 1 over ln 2 plus c. So what does c actually equal? 5 minus 1 over. So now what is the actual final equation going to be? What's the actual final? You take this c and where do you plug it in? So you get y is equal to 2 to the x over ln 2 plus x cubed plus what? 5 minus 1 over ln 2, right? I like putting the parentheses around it just to emphasize the c value. Does that make sense? Arvin, do you see what you need to do instead to get the c value? Yeah. You have to plug it in and be really careful because in this case, what is 2 to the 0? Not in this case, just in all cases, 2 to the 0 is 1, exactly.
I have a question.
Yeah, go ahead.
So
we talked about the general solution, right? And we talked about differential equation. What was there's another word in there I didn't mention that you didn't explain. The what? The what order?
First order?
Why is it a first order? What derivative are we looking at? The first derivative, right? So what do you think a second order differential equation is? Second derivative. Have we looked at second derivatives before? Yeah, you're just so excited about this, I know. So here's what it says. It says, so we have the second derivative of y with respect to t is equal to what?
-4y.
Do you agree with that? So we need to, what did you say we need to do? Noah? Find the antiderivative. So do that. That does not seem like something we can integrate too well. So let's go the other direction and see what happens here. So you need to try to remember your differentiation rules, which I think you guys remember. Can someone tell me what the first derivative of this is going to be? I'll zoom in. What?
2t.
Nope. Can someone tell me what the derivative is going to be? Can raise your hand when you think you have it. This is straightforward. There's no. So it's e to the 2t times what?
2.
Times 2. It's the chain rule. It kicks out the derivative of that. Don't write anything down. You're doing this verbally with me. So let's clean this up a little bit. We have y prime is equal to what?
2e to 2t.
Is that correct? Nice. So if we want to take the second derivative, what do we do? So what's it going to be? Not product, because 2 is just a constant. What's the derivative going to be?
4e.
What'd you say, David?
4e.
To the?
2t.
Yeah. Do you agree with that? You look confused. We just did it again, but what's outside now? 2. Let's try that one more time, everybody, because we're seeing a little bit of confusion there that I want to make sure isn't there. What's the derivative of this, Andrew? What's the derivative of that, Andrew?
2e to 2t.
Yes. So now you're doing the derivative again. You're doing the exact same thing, except what's already out front.
2.
So another way to say this is 2 times 2e to the, which is what? 4e to the what? Okay, are you with me so far? Okay.
Mr. Seamon, can I ask a question just about like?
Nope. We're gonna finish this one, and then is it about what we've done so far?
No. It's
No. So we're gonna stop this here. We're gonna go right here then. Okay. You with me so far? So we're trying to see, is this the same thing as this? So notationally, everybody, notationally, what's another way you can write that? What's a different notation for that? Well, that's this right here. This notation is the same thing. These things are the same. I'm just telling you, it's the same way. It means second derivative with respect to t. So this equals 4e to the 2t. It equals 4e to the 2t. We're not quite there yet, though, are we? What's the original thing we know over on the top left? What's the original thing we knew? What does y equal? What does y equal? So hold on. So we have the second derivative of y with respect to t is equal to what? 4 what?
4y.
4y. Look, everybody. Do you see it? Does everybody see it right there? Look at the highlighted green. Y is e to the 2t, right? So tell me something. Is this the same thing as this?
No.
Yeah, it is.
Is it?
Yes. Oh no.
Is it?
It's minus 4y.
Minus. Look, if you were to put this on the same side, what do you get? Minus 4y is equal to what? So is that a solution?
No.
No. It's not. It's not. So if you're given a solution, the only thing I want you to walk away from on this is if you're given a solution, you can go in either direction. You can try to integrate or you can try to differentiate, but you know that in general what's true. Differentiation is easier than integration in general. Is it always the case? No. Like, could I give you something that's terrible? There are ways I could make it not true, but in general, what's easier, factoring or multiplication? In general, multiplication in general is easier, right? In the world of math, the way we say that is multiplication is fast, factoring is slow. Like, it's very important that that's true, or like encryption doesn't work very well at all. Okay, sit down, everybody. 2 to the t, right? But then what do you need to multiply it by? The derivative in terms of t of 2 to the t. What is the derivative of 2 to the t? Yeah, it's e to the, so this stays there, right? But then what is it? ln 2 times 2 to the t. Exactly. If that was written that way, correct. But what is it over here? That's not what it is, right? It's 2 times t. So do you understand it's very, very different? That's a great question, though. So does that, changing a little bit of where that t is, changes it a lot. Does everybody see that right there? What rule is causing this to happen right there? What rule is that? The chain rule. Yes, this happens because of the chain rule. Exactly. That happens because of the chain rule. Again, you have to know. You have to remember it. So, this one is dy dx is equal to 7. Thank you. 7x minus 2 to the what?
-1.
No, 2x to the, 2x to the -1, exactly. You just need to know what the integral of x to the -1 is. What is the integral of x to the -1? So it's 7 over 2 x squared minus 2 what? What is the integral of x to the -1? ln of x. You just have to know that. That's just, I put the absolute value in and you will get a lot further in calculus later in life. You just have to know that, everybody. Do you remember you just, and kids, once you just have to know this right there. There's the integral. That's one of the ones you have to memorize. You have to know that.